Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are going to help the students who are preparing for CSIR NET, GATE, NT exam, PhD exam, SET exam, IIT-Jam exam, Jest, TIFR and other exams related to physical science. Okay, so guys, today I'm going to teach you mathematical physics. It is the lecture number 11. Okay, so we are going to solve matrix uh, related problems. Okay, and before starting the class, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free lectures which are going to help you to crack the exams related to physical science. Okay, so before starting, let me just check the audio. Is it audible or not? The students who, yes, it's working. Okay, so this is the lecture number 11 of mathematical physics. So I'm going to start. And so here we are going to study inverse of matrix. Okay, inverse of matrix. We have already studied the basic definitions of different types of matrix, and we have also solved questions related to matrix, right? And about adjoint and properties of adjoint, which we have already done in uh, previous class of matrix. Okay, so this is the second class of matrix, and this is the lecture number 11. Okay, so so it is inverse of matrix which we are going to study. Okay, so here we know if AB are two matrices, okay, then AB equal to BA, okay, if AB equal to BA, that is I, okay, if AB equal to BA equal to I, in that case we can write EB equal to I, okay, or we can multiply by A inverse on both sides, so it is going to be A inverse A equal to, this is going to be A inverse I, right? So this is going to be now A inverse A, we know that is I, right? So this is I, this is B matrix, and this is A inverse. So if you multiply uh, any matrix with identity matrix, that is going to be the same matrix. Okay, and so it means, and this is also, this means, this implies B equal to A inverse. Okay, B equal to A inverse. Okay, yeah. So B is the inverse of A. Okay, next point. This formula we know, right? A into adjoint of A, right? this this is equal to determinant of A I, right? This I have already explained. This we know since. So I'm writing next page. Since determinant A not equal to 0 for this case, okay? Yes, I can write here as well. Determinant A not equal to 0. Okay? This we know. So I solve this. So it is going to be now. So what we can do in this expression, which we already know, we can multiply both sides by A inverse from left hand side. Okay, so this is going to be A inverse A inverse adjoint of A inverse adjoints of A is going to be A inverse determinant of I, right? From in this expression we have multiplied by A inverse on both sides. Okay, so this is going to be, so this is A is also there, right? A inverse A is going to be I, we know, right? A inverse A, that is I adjoint of A, right? This is going to be, determinant will take outside, and this is going to be A inverse I, right? So this is going to be adjoint of A, okay, is going to be determinant of A inverse, because if you multiply identity and identity matrix with any matrix, that is going to be with the same matrix, right? This is determinant of A, guys. Determinant of A, we have taken in left hand side. Okay, so now from here we can easily find A inverse. Very important formula. A inverse is adjoint of A upon determinant of A. Okay, so this is the, so we can by this formula we can easily find out the inverse of any matrix. Okay, so we just have to find out adjoint of A and determinant of A, then we'll put this value, these values in this expression, and we'll get the A inverse, right? And I have already explained how to calculate A adjoint of A, right? And you also determinant of A. So this is the A inverse, guys. Inverse of any matrix is adjoint of that matrix upon determinant of that matrix. Very important formula, guys. Okay. Next property of inverse is non-similar matrices are invertible. Okay. Non-similar. Non-similar means whose determinant is not equal to 0. I have already explained it. Okay. In my previous lecture. So this is non-similar matrices. Non-similar matrices. Non-similar matrices are invertible. Okay. Next point. And also this property we know that determinant of A inverse, very important property, is equal to 1 upon determinant of A. Okay. So determinant of A inverse is equal to 1 upon determinant of A. Okay, this is also very important property. These are the properties of inverse matrix. Next point, and this we know, right? AB inverse, this we know how to open it. It is going to be B inverse into A inverse. Very important property. This type of property we have already I have already explained in quantum mechanics, the dagger one, right? You know how to open the dagger. That is Hermitian, right? Hermitian operator. Okay. Next is, suppose we have to find ABC inverse, right? So how we'll open it? It is going to be C inverse, B inverse, and A inverse. Okay, means AB means B first, then A. If it is in ABC, right? So the last one will come first, then second last one, then third one, then the first one, right? Similarly, if there are 4, the last first, then after that, and after that. If A, B, C, D, then D first, then C, then B, then A, right? This would be in reverse order. Reverse order. Okay. Very simple. You already know it. Okay. So this is the one. And next is very important property. This is also of A inverse. So A inverse transpose of A inverse is going to be, this is going to be equal to inverse of transpose of matrix. Okay, okay, so this one. So transpose of A inverse is equal to inverse of transpose of A. Okay, very important property. So these are the properties of inverse matrix. Okay, I'll solve one question, simple question. Question number one. This is we have given A. A is given. Okay, so this is 1 1 1 0 2. Okay, this is given, and we have to find A inverse. Okay, how to find I will explain now. Okay, so A is given. Means A is 1 1 0 2. A is 1 1 0 2. Okay, so for finding out A inverse, first we'll find the matrix of cofactors. Okay, that is B will find. So this we we know, right, how to find it. So for this is going to be like B will find A11, A12, A13, A12, A12 or A22, right? For finding like that, what we are going to do, A11 is going to be this one, right? This row will get cancelled, this row will get cancelled. So this is going to be 2. I have already explained how to find the adjoint, right? So here I'm going to write like this. So this is going to be 2. 1 1 means minus plus 2. Okay. Now for this, for 8 1 2, this row this get cancelled. This is 0. For this is the matrix of cofactors. Okay, and A12, this one, right? This row get cancelled. This one, and 1 3 1 3 1 2, right? So this is minus. So this is going to be minus 1. Minus 1, and then this one 2. This line, this is 2 2, this is 1. So this is the one, right? Now this is the matrix of cofactors. This we know, right? I have explained in last lecture, so you can watch my last lecture. So now we'll find adjoint of A. Adjoint of A is going to be transpose of matrix of cofactors, that is B, right? B transpose. So this is going to be, will exchange the columns and rows. So this is going to be 2 minus 1 0 1. Okay, 2 minus 1 0 1. Okay, so this is the one, right? Now we can easily find the A inverse by the formula which I have already, this one I have already explained. Okay, so this is going to be adjoint of A upon determinant of A, and we know how determinant of A is this one, right? Determinant of, so this is going to be 1 into, sorry, this is going to be 2 and the 2 0, 2 minus 0, so this is going to be 2, right? So this is the determinant. So now we'll put the value. So this is going to be A inverse is going to be A inverse is going to be adjoint of A, this matrix, upon determinant of A. Determinant of A is 2, right? So this is going to be 1 by 2, and then the matrix is this one, 2 minus 1, 2 minus 1, 0, 1, 2 minus 1, 0, 1, 2 minus 1, 0, 1. Okay, so this is going to be 1 minus 1 by 2, 0, 1 by 2. Okay, this is A inverse. Okay, so this is 1 minus 1 by 2, 0, 1 by 2. Okay, this is the A inverse. We find the A inverse, and so we can easily find it because if it is 3 cross 3 matrix is given, then also we can easily find out, right? Because I have already explained how to find adjoint. You just need to find adjoint, which I have already explained. So find the adjoint for the matrix and calculate the determinant, and then put these values in this expression. You will get the inverse of it. Very simple, which we have also studied in 11th and 12th. Okay. Okay. So this is about A inverse. Next we are going to next we are going to discuss. Next topic is trace of the matrix. Next point. Okay. Of property. Trace of the matrix. Trace of the matrix. Okay. What is the trace of the matrix? That we'll study now. Trace of, okay, trace of matrix means sum of principal elements of the matrix. Okay, principal diagonal elements of the matrix. Okay, so trace of the matrix means sum of principal diagonal, sum of principal diagonal elements, sum of principal diagonal elements of the matrix, of the matrix, sum of principal diagonals, sum of principal diagonal elements of the matrix. Okay, or a principal diagonal element also we can denote as PDE. Okay, that is principal diagonal element in short. Okay, so sum of principal diagonal elements of matrix is called trace of the matrix. Okay, okay, so this is the definition of trace of the matrix. I'll explain now by giving examples. Suppose we have given a very important property, right? 1 2 3 2 1 4 and 5 7 1. Okay, this is the A given. Okay, so A is given, right? So so now we can easily find the trace of A, right? We can denote trace of A is like that. In short, trace of A is going to be sum of principal diagonal elements. So these are the principal diagonal elements. Okay, this sum of principal diagonal elements. Okay, so this is 1 plus 1 plus 1. Okay, this is 3. Okay, so trace of A, trace of any matrix is sum of principal diagonal elements in this matrix. In this case, 1 1 1. These are the principal diagonal elements. We'll add it. So this is 3. So trace of A is 3. Right? Very simple, guys. Next property of trace is trace of A to be trace of A plus trace of B. Okay. And next property is trace of AB. So this is going to be, okay, so trace of AB is equal to trace of B. A plus B is trace of A plus trace of B, and trace of AB is equal to trace of B. Okay, so order of the matrix doesn't matter, right? So it may be AB or BA, right? That the value will be same. Okay, So this is the property. Next property. Okay, I'm just checking this network. Okay, I think it's working fine. Next property is very important, guys. Okay, you will get questions related to these properties. Okay, the first property is sum of eigenvalues, sum of eigenvalues, sum of eigenvalues of a matrix, sum of eigenvalues of a matrix is equal to is equal to the matrix. Okay, this is sum of eigenvalues of a matrix is equal to the trace of the matrix. Okay, so suppose we have 3 cross 3 matrix. Okay, and we need to find sum of the and their and eigenvalues are lambda 1, lambda 2, and lambda 3, right? So in that case, uh, what this statement is saying, in that case, sum of eigenvalues lambda 1 plus lambda 2 plus lambda 3 is going to be equal to trace of the matrix. Okay, so trace of the matrix. So suppose matrix is a trace of the matrix. Trace of matrix means sum of the diagonal element. Okay, for example, this is a matrix. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is the matrix. Okay, guys, and suppose the the eigenvalues are lambda 1, lambda 2, and lambda 3. Okay, okay, so in that case, lambda 1 plus lambda 2 plus lambda 3 is going to be trace of the matrix. Okay, trace means sum of the principal diagonal element. So that is 1 plus 5 plus 9. Okay, so this means lambda 1 plus lambda 2 plus lambda 3 is going to be equal to 15. Okay, so this is the property, right? Very important property. Next property. I hope you understood it, guys. This is just an example I have given. Okay. Next. Next is next point is also very important. This is the product of eigenvalues. The product of eigenvalues. The product of eigenvalues of the matrix of a matrix is equal to is is equal to is equal to the determinant of A. Okay, equal to the determinant of the matrix. Okay, this property is the product of eigenvalues of a matrix is equal to the determinant of the matrix. Okay, for example, suppose we have a 3 cross 3 matrix, and that matrix is A. Okay, we have a matrix A. Okay, and the eigenvalues of matrices are lambda 1, lambda 2, and lambda 3. Okay, so what this statement saying, the product of eigenvalues. Okay, so lambda 1 into lambda 2 into lambda 3 is going to be equal to the determinant of matrix. So this is matrix, this is determinant of matrix. Okay, so lambda 1 into lambda 2 into lambda 3 equal to determinant of A. Okay, this is also very important property. So we can solve many questions using these two properties, sum of eigenvalues and product of eigenvalues, and the question will get solved very quickly. Okay. compared to the typical method. Okay, so these are the properties of traces. Right, now we are going to study rank of the matrix. Okay, rank of the matrix. Rank of the matrix. Rank of the matrix. Okay, so this is rank of matrix means number of non-zero rows in upper triangular matrix. Okay, so rank of, for finding the rank of matrix, if we find the number of uh, rows of the in the upper triangular matrix, right, that will be the rank of the matrix. So rank of matrix is number of non-zero. I will solve it by example. Okay, I'll explain it by example. So number of non-zero rows, number of non-zero rows in the number of non-zero rows in upper triangular matrix, in upper triangular upper triangular matrix. Okay, so rank of matrix means the number of non-zero rows in upper triangular matrix. Okay, I have already explained what is upper triangular matrix in my previous lecture. Okay, so for upper triangular, I'll give the example like, so this is like 1 2 3 0 4 5 0 0 3, right? So the elements below the principal diagonal line, if elements below the principal diagonal line of principal diagonal element are 0, these elements are 0. Okay, these are below the principal diagonal line, right? In this matrix is called upper triangular matrix. Okay, all the elements below the diagonal, the matrices whose all the elements below the principal diagonal line are 0, called upper triangular matrix. Okay, okay, so this is about upper triangular matrix, which I have already explained. Okay, so now I will solve a question and then it will be uh, more clearer to you. Okay, question 2. This is, we have given a matrix A equal to 1 2 3 2 5 7 2 5 7 and 3 6 3 6 10. Okay, so this is 1 2 3 2 5 7 1 2 3 2 5 7 and 3 6 10 3 6 10. Okay, this is the matrix which is given and we have to find the rank of the matrix. Okay, the rank of the matrix, rank of the matrix. Okay, so I will solve it for you now. Since A is given 1 2 3 2 5 7 and 3 6 10. Okay, this is the given matrix is given. Okay, so what we have to do is, our first aim is, if any so if we have to find the rank of matrix, first of all we have to write the matrix and we have to convert that matrix into upper triangular matrix. Means we have to make these elements, these three elements, means the elements below the principal diagonal line, we have to make these elements 0, right? And then we'll count the row, non-zero rows. Okay, and and then those rows, the number of rows will be the rank of the matrix. Okay, so okay, so now we'll make these elements 0. So how we are going to do is we'll we'll do operation here. Okay, so this is first we are going to we are going to do operation at R3. R3 means this is R1, this is one row, second row, third row, R1, R2, R3. We can say, okay, so this is R1, first row, R2, and this is R3. Okay, and these are C1, C2, C3. This is C1, C2, C3, the column, right? So here we are going to do operation in rows. Okay, first operation is we'll do in R3. So this is going to be R3 tends to R2 minus 2 R1. So we can do like this. Okay, so we are going to operate this R3 and how R2 minus R3 minus 2 R1. Okay, R3 minus 2 R1. Okay, so if you do that, so this is going to be first row will be as it is. Okay, and second will be also same, and this R3 here we have done operation, right? So R3 3 minus 2 R2, right? So this is going to be 3 R2 because we have to make it these elements 0, right? 3 R2, so it is going to be 0. Okay, and then here the same R3 minus 3 R2, 3 to the 6. This is also going to be 0, and then this is 1 because 10 minus 3 3 is a 9. Okay, 1. Now we'll we'll do second operation, that is in R2 row, R2 equal to, because we have to make these elements 0, right? So these two got 0, right? Now this element we have to make a 0 so that we can convert this in upper triangular matrix. Okay, so this is R2. We are doing the operation in R2 minus 2 R1. Okay, so R2 minus 2 R1, right? So then it is this element is going to be 0. So then this matrix is going to be right here. Okay, so this implies matrix A is going to be this is going to be first row will be as it is. Okay, R2 minus 2 R1. So this element is going to be 0, and next element is going to be 1 because 5 minus 2 R1, 2 to the 4, right? And this element is going to be 1, and this is 0, 0, and 1, right? So now here you can see so you can see that we have made these three elements 0, right? So it now it is upper triangular element matrix, right? So we have converted the matrix A into upper triangular matrix. Okay, by using operations. Okay, so now what we have to find out the number of, so we know the definition of that rank of matrix, right? Number of non-zero rows, right? So now it is converted into upper diagonal upper triangular matrix, right? So now number of rows, number of non-zero rows means, then there shouldn't be any 0, right? So this is one row which is non-zero, this is second row, okay, and this is third row, right? So 1 2 3 three row is 3, right? So the rank of matrix is 3 because number of number of non-zero rows in upper triangular matrix. So this one is non-zero, there is no any 0 element, right? This is one row, this is second row, this is third, this is 3. So rank of matrix is 3. I hope you understood, guys. Very good question, guys. Okay. So the rank of this matrix is 3. Okay, well, now next question. Question number 3rd. Okay, this is also very good question. We have been given A equal to 1, 2, 3, 2, 4, 3, 6, 9, 8. Okay, 6, 9, 8. This is the A given. Okay, A is given. A is given. This is 1, 2, 3, 2, 4, 3, and 6, 9, 8. Okay. So now we have to find the similarly we have to find the rank of matrix. Okay, we have to find rank of matrix. Similarly, so now again we'll convert this matrix into upper triangular matrix. Okay, so again we'll do the operation. Okay, so here what we are going to do is the first operation we are going to do R3. Okay, R3. This is third row of R1. Third row of the matrix R3 tends to R3 minus 6 R1 we are going to do. Okay, so our aim is to make these 3 elements 0. These 3 elements are the elements which are below the principal diagonal line. Okay, if these become 0, then this matrix is going to be converted into upper triangular matrix. Okay, so if we do that, then A is going to be 1, 2, 3, and 2, 4, 6, 2, 4, 3 is going to be same, and this is going to be this R3 minus 6 R1. This is 0, and this is minus 3, and this is minus 10. Okay, hope you know this operation, guys. We have also studied this in class 12 or 11. Okay, so now second operation we are going to do. Second operation is R2. In second row we are going to do R2 minus 2R1. 2R1. Okay, R2 minus 2R1. If we do that, so R2 minus 2R1. 2R1 means this minus this. Okay, so this is going to be 0, and this is also going to be 0. 2 to the 4, right? So now the matrix A is going to be 1, 2, 3. First row will be same. In second row, this is going to be 0 because we have done operation here minus 3, and third row is like this 3, 0, minus 3, and minus 10. Okay, this is given. But now we have to convert. This is not in upper triangular matrix form, right? Here this would be 0. So what we can do is, so this is also very important property, guys. If we change any columns or row, if we exchange columns and row, that is not going to affect the matrix, right? This is the property you should know. So here what we are going to do, we are exchanging R3 into R2. We are exchanging R3 into R2. Okay, we are exchanging R3 into R2. So this we are exchanging R1, the rows of R1 and R2. So our row, this row R3 is going in second row, and second row is going in third row. So this is going to be A equal to 1, 2, 3. These rows we have exchanged. So this row will go to R2. This R3 row will go in R2. So this is going to be 0, minus 3. Sorry, 0, 0, minus 3, minus 10. That's correct. And this is going to be 0, 0, minus 3. So we can exchange the rows or columns. Okay, that is not going to affect the matrix, right? So now you can see that this is the principal diagonal line, and below these lines, these elements are 0. Means this we have converted. Now this is in the form of upper triangular matrix. So this is converted into upper triangular matrix. Now simple, we have to the number of non-zero rows. There is no zero term, right? This is one row. This this is second row, and this is third row. Okay, number of non-zero rows of upper triangular matrix is the rank of matrix, right? So this implies rank of matrix is this one row, two row, three row. This is three, rank of three. Rank of matrix is three. Okay, so I hope you understood it, guys. Okay. Next question we are going to solve. Next question is okay. Next is, this is also very good question. Question number 4. This is A is given. This is 1 1 1 1 1 1 1 1 1. Okay, this is the A given. Okay, A is given 1 1 1 1. Okay, and we have to find the rank of matrix. We need to find, and options are given. Option A is 3, option B is 2, option C is 1, and option D is 0. Okay, so we have to find the rank of the matrix. Okay, so how we are going to find? Since A is given, right? So we'll do the operation. Okay, so this is going to be A is 1 1 1 1 1 1 1 1. Okay, this is the A which is given. So our aim is to convert this matrix into upper triangular matrix. Okay, so that we can count number of non-zero rows, and that will be the rank of the matrix. So here we are going to do the operation. The operation what we are going to do is, so this we are going to do is, there are two operations we are going together. So this is in R2, in second row, this is going to be R2 minus R1, and second operation is R3, which is going to be R3 minus R1. Okay, so that's what we have. So in this one, this R1, R2, R3, right? So in R3 we have done R3 minus R1, and in R2 also R2 minus R1. Okay, this operation we have done, so we are going to do. So now this is going to be, A is, R1 will remain as it is, 1 1 1, R2 minus this one, R2 tends to R2 minus R1, so this is going to be 0 0 0, third is going to be 0 0 0, right? Got it? Yes. Now see, so we have converted this into upper triangular matrix, because if we check this diagonal line, below diagonal line, all elements are 0. Okay, now we have to count non-zero number of rows. Okay, non-zero number of rows. This is the one row. This is not going to be row because it is not non-zero, because there is 0, and this will also not be counted because this is also not 0. Means there is only one row after converting this matrix into upper triangular matrix, right? So there is only one row. Okay, so this means rank of matrix is 1. Okay, so which option is correct? Option number C is the correct one. Okay. Okay, so now we are going to solve next question, which is very important question. Question number 5. Okay. Question number 5. This is very good question. Okay. This is we have been given A matrix is given. This is 1 1 1, and then A B C and then A cube, B cube, C cube. Okay, so this is the matrix which is given, and we need to find and also rank of matrix is given. Rank of matrix is 3. Okay, this is given. Okay, and this is 3 cross 3 matrix, we already know. Okay, so and also it is written A, B, C are real numbers, are real numbers. A, B, C are real numbers. Okay, okay, so we have given a matrix and its rank and ABC are real, and we need to choose the we need to select the correct option. Okay, an option are given. So matrix is given, rank is given. Okay, and ABC are real number. That is what given. Okay, we have to select now the correct option. First option is if A equal to B equal to C. Okay, and this is given A equal to B equal to C, and option B is given. Option A is given A equal to B equal to C. Okay, option B is given A, B, C are different, not equal. Okay, are different. A, B, C are different, uh, and A plus B plus C equal to 0. Okay, and option C is given A, B, C are different. A, B, C are different. Okay, A, B, C are different, but A plus B plus C not equal to 0. Okay, but A plus B plus C not equal to 0. So these three options, and fourth option is 0. Okay, so these options are given. Okay, we have given matrix and rank is also given, and ABC are real numbers, that is given. So we have to choose the correct option. First option is A equal to B equal to C. Second is ABC are different, but A plus B and A plus B plus C equal to 0. Third option is ABC are different. Okay, the values of ABC are different, so they are not equal. Okay, but A plus B not A plus B plus C not equal to 0. Okay, option D is 0. So this is a very good question, guys. Okay, this is asked in examination. Okay, so now we are going to solve it. Okay, so we have been given A equal to, I hope guys. Option. First option is A equal to B equal to C. Second is A, B, C are different, but A plus B and A plus B plus C equal to 0. Third option is A, B, C are different. I'm just checking the sound.
I hope guys.
I'm just checking the sound. Okay.